second grade students. It's good to see everyone today. Happy Thursday. Today we're going to do a read along, reading the story that's in readworks.org called Up to Speed. And then we're going to be talking about adverbs, which should be pretty quick. It's actually the easiest thing out of your grammar packet. All right. So we're going to go ahead and jump right on to readworks.org. Now, the story today is called Up to Speed, and it focuses on the physics or the science and a little bit of history of one of my favorite things. If you're paying attention to yesterday's video, one of my favorite things out there, and that's roller coasters. We're going to do a quick science lesson throughout the story because it's more science than reading. But the reading level is going to be quite difficult. So if at any point you need to stop the video and rewind and reread something, please do. And go back, because I want to make sure that you understand things as we read. All right, so we're going to go ahead and get started. The story will look like this on your readworks.org page. And if you take a look, the picture is, I didn't know what it was at first until I took a look, and it's a pretty intense roller coaster. That looks really high up. Now think about what we already know about roller coasters. They're fun. They go fast. Some are tall, some are short, but for the most part, they're an enjoyable ride. What we're going to focus on today is the science. Now, if you look behind me, you will see two words, actually three words. The first word up there is potential. The second word is kinetic. Now, as we read through here, we're going to be hearing the words potential and kinetic quite a bit. Now, these are adjectives to describe a type of energy. So as we read, we're going to stop here and there and talk about potential and kinetic energy. All right, so now we're going to go ahead and begin reading. We're going to start with the subheading called Thrill Ride. Kinetic is one wild ride. As you wait in line, you hear the screams of people riding the roller coaster. Part of you can't wait to ride it. Another part of you wants to bolt in the opposite direction. Before you know it, it's your turn to board. You brace yourself. Whoosh! Well, there's an onomatopoeia right there. Whoosh! With a roaring blast, the thrill ride rockets from 0 to 128 miles per hour in 3.5 seconds. Think about that for a second. In 3.5 seconds, it goes 128 miles per hour. That is insane. Before you can catch your breath, the train whisks you straight up 456 feet. When it can go no further, gravity plummets the coaster downward into a dizzying spiral twist. The train then whips through another valley and zooms up another hill. Congratulations, you have just experienced one of the fastest and tallest roller coasters on Earth. That sounds insane, doesn't it, guys? I love roller coasters, but I don't know if I would go on that one. How many of you would go on it? 456 feet up in the air. That's crazy. That's crazy. That's like going up at the top of a skyscraper and coming down really quick. Whoosh. All right, next part. King of coasters. Kinetic Energy, or King of Coasters, opened in the spring of 2005 at the Six Flags Great Adventure theme park in Jackson, New Jersey. The jaw-dropping thrill ride shattered the world record for roller coaster speed and height when it opened. Of the more than 1,000 roller coasters in the United States, it was the latest extreme coaster to be built. Six Flag roller coasters designers Larry Chicola said that the building of Kinetic Energy wasn't easy. We considered the wind strength, the possibility of earthquakes, the weight of Kinetic Energy itself, as well as the forces you caused by launching a coaster faster than one has ever gone, he told the Weekly Reader. Think about that. Think about the design of that. When you're just building a coaster, you have to think about things like gravity. You have to think of things like wind. There's a lot to think about when we're dealing with roller coaster design. Wow, those pictures looked insane. I don't know if I could do it. As much as I love roller coasters, just looking at that, I don't know if I could do it. I'd probably be the one to run out of line. And as much as I love roller coasters, don't get me wrong, that might be too extreme for me. How many of you would actually try it though? Well, I bet there's a few of you that would try it, and I bet there's a few of you that would join me in running the other way. So the next part of what we're going to read, it's subheading called How Coasters Work. Now this is where we're going to run into the potential versus kinetic energy. So as we read, see if you can come up with your own definition of potential and kinetic energy before we discuss it at the end of it. Okay? How coasters work. Changes in energy enable roller coasters like Kinetic Energy to move for most of the ride. According to scientists, energy is the ability to cause change. At the beginning of the ride, Kinetic Energy blasts passengers to a speed of 128 miles an hour, with technology similar to the kind that launches Navy jets from aircraft carriers. Each train on Kinetic Energy is hooked up to a hydraulic cable. Liquid under high pressure is pushed through the cable along with motors. The hydraulic power rockets the coaster skyward. After reaching the top of the first hill, the coaster works in the same way your bike does when you roll, pedal free down a slope. Another word for slope is a hill. When a roller coaster is stopped, it has potential energy or stored energy. At any moment, the coaster can move, so it has the potential for motion. As the roller coaster starts cruising, gravity takes over and converts or changes the potential energy into kinetic energy, which is energy of motion. The repeated change of potential energy to kinetic energy and then back again drive the roller coaster. So, if you're thinking about what I asked you to do before, what is the difference between kinetic and potential energy? Well, potential energy is stored energy, which means it's not moving. Now, I will tell you, things on the ground aren't moving, but they don't have the most potential energy. Why? Because they're on the ground. But let's say you you ride your bike up a hill. And you get to the very, very top, and then all of a sudden you stop. And you're looking down that hill. You have way more potential energy at the top of the hill than you do at the bottom. Why? Because you put the energy into the bicycle by taking it up the hill. A roller coaster works the same way. You add potential energy up, and the higher you go, the more potential you have. Imagine, or if you take a look at the egg drop experiment that we did last week, in fact, they used water balloons instead. If I was only about 2 inches off the ground and I dropped the water balloon, would it break? Probably not. But if I was 20 feet up in the air and I dropped the water balloon, would it break? 100% yes, it would have broken. Why? Because you're adding more potential energy the higher you go up. Now, the higher you go up in that potential energy, the minute it starts moving, it turns into kinetic energy. Now, think of kinetic energy as energy through moving. The faster something is moving, the more kinetic energy it has. Think about the Kinetic Energy. It moves at 128 miles per hour. That's faster than some race cars. At its highest point, it has the most stored energy or potential. But as it's going down, it's working with gravity and kinetic energy. And it will have the most energy at the bottom of the hill. I'm going to show you a picture in a second to show you how this works. So in this diagram, I'm using a bus to show you how it works. Now, I don't have a Matchbox or a Hot Wheel with me right now, so we're just gonna have to imagine that that's actually a bus. Or we could also think that it's the top car in a roller coaster as well. So if we look at our slope, the highest level of potential energy is right here at the very top of the hill. Now, as the bus gains kinetic energy, now if you remember, this bus is going to only move if I move it. So it's going to gain kinetic energy by having me move it and slide down the hill. Now, when it's right here, would it be going that fast? Probably not. The kinetic energy hasn't had time to really change from potential to kinetic yet, has it? So where is the bus going to be going the fastest? Well, we have to go down the hill and build up that kinetic energy as best we can until we get to the point where it levels off. Now, it's at this point at the bottom of our hill that we will have the highest level of kinetic energy, which means right here, it's going to be going the fastest. So along with the changing of energy from potential to kinetic, we also have the force of gravity pulling that bus or that cart down. So add all those factors in. When you're designing a roller coaster, there is so much science that you have to figure out. Now, let's finish the story so you guys can get to the questions. The next subheading is called It's a Scream. Kinetic Energy covers 3,118 feet of track and lasts less than a minute. To roller coaster buff Steve Urbanowitz, I think that's how you pronounce his name, from New Jersey, the ride is a scream. The ride seems like it's over really quickly, but Kinetic Energy packs 8 high moments of drama into those 50 seconds, he told weekly reporters. Urbanowitz, sorry I messed up that name, speaks from experience. He has ridden more than 800 roller coasters around the world. In fact, he has taken more than 5,000 rides on one in particular, the Wooden Cyclone at Coney Island in Brooklyn, New York, where the first true American coaster opened in 1884. I loved going to amusement parks when I was a kid and never grew out of it. I certainly understand that. All right, last subheading, cool coasters. We got 3 major bullet points here. 1, the idea for the roller coaster was born in Russia in the 1600s when huge blocks of ice supported by wood were made into sleds. Straw or fur covered the icy seats. Probably not one I'd want to ride, but it probably would be fun. 2nd bullet point. Coney Island in Brooklyn, New York is credited with being America's first amusement park in 1875. The nation's first coaster opened there in 1885 and cruised all of 6 miles per hour. So, a little math question. This is your bonus question for today. What is the difference in speed between Kinetic Energy and the first roller coaster? So you're going to have to subtract. Put your answers in Class Dojo, and I'd love to see your answers. And the final bullet point. Some of the best coasters of all time were built during the 1920s. That era reigns as the golden age of amusement parks. By the end of the decade, the stock market crash of 1929 and the Great Depression caused many parks to close. I remember an I Ready story that we read that talked about parks like that. In fact, I think we read one that was about Coney Island as well. So a lot of this should be review. So I hope you enjoyed the story. Go to readworks.org, answer those questions. If you need to go back into the story, go back into the story, reread it, re-listen to this video, re-watch this video. I do these to try to help you. And sometimes, like I said before, it's easier to understand a concept when your teacher's kind of reading it along with you. The next thing I want to talk about is I believe the final page in your packet. Now, this page will look something like, I'll just find it here. All right, there we go. It'll look something like this. It says adjectives to adverbs. In fact, it says Thursday right at the top. Now, this week we've talked about conjunctions, prepositions, interjections, and now adjectives to adverbs. Today is going to be really simple. If you read the directions, you'll see just how simple this is. Now let's talk about adjectives real quick. Adjectives are used to describe nouns. They can be colors or descriptions of a noun. All right, so describing this mouse would be, it's a red, white, and blue mouse. Red, white, and blue, adjective. The PlayStation controller is camouflage. Camouflage would be the adjective. All right. Now, adverbs do the same thing as adjectives, but instead of describing nouns, an adverb describes a, verb. It's actually in the word adverb itself. So if you look at number 1, it says the word beautiful. And what we need to do is add an ly. So the word becomes beautifully. Can you describe something that you do that's as beautifully? Well, I sing beautifully. Well, no, you know that's not true. I dance beautifully. That's certainly not true. But the word beautifully would be used there to describe how a person dances or how a person sings. Number 2, happy. Okay? We change happy to happily. Now, in this case, we change that Y to an I. Okay? The first Y in happy. So it's Happily. Happily can be used to describe how someone is living, how someone is feeling. But either way, when we change it to an adverb, it is used to describe that verb. All right? So, this Thursday packet, this Thursday work should be fairly easy. Okay? Now, tomorrow, you will have a grammar test that's already in your packet of work. I'd love to see what you do. Now, feel free, I even wrote a note on it, to go through it and try to do what you can at first, but then use the packets that I gave you inside your folder to help you answer the questions. Use them as a resource. I worked with a student today, hi Selma, today, and we went over the whole thing, and the packets help. So please do your best, and that's all I ever ask of you. Just do what you can, do your best. I'm proud of you no matter what. So, what did we review today? What did we talk about today? Well, potential versus kinetic energy. We talked about some sick roller coasters. You're going to answer some great questions on readworks.org. And we've talked about an easy part of speech in which all we have to do is change the word a little bit and add an ly and use it to describe verbs. All right? So, good luck with your work today. I'm proud of each and every one of you. Until the next time, I will see you later. Miss you.